Hi, my name is Patrick Collins. I'm SELCO's energy analyst, and we're here today at the 1830 Brick Schoolhouse with Nick Lupo from Control Point Mechanical. We're going to be seeing the installation of an air source heat pump system. Last year we were here for an energy audit, and that was performed by the Center for Eco-Technology, CET, and they identified some needs for some significant weatherization, including attic insulation and air sealing, and that will be performed after this heat pump installation. You can see the whole energy audit video on Shrewsbury Media Connection, and you can schedule your own free home energy audit by visiting nextzero.org or calling 888-333-7525. Nick's here going to talk about why we're here and what we're installing.
Hi Patrick, thanks for having us. We appreciate you trusting Control Point with the schoolhouse project. What we're going to be doing here is installing air source heat pumps, cold climate heat pumps that are going to provide a year-round heating and cooling solution for the brick schoolhouse here. And we're going to be installing two systems outside with four indoor distribution heads. Part of the design of this particular system was to offset the oil consumption in the building. So the system we've designed here is capable of handling year-round heating and being effectively turning off the oil or only use it as a backup system.
So the modeled energy savings for this project is estimated to be around 63% reduced total energy consumption and a reduction of 20 tons of carbon per year. That's switching from oil to electric heat pumps. That will result in an estimated savings of almost $3,500 per year in energy savings.
So a heat pump is an all-electric heating and cooling solution for your home or business. In this situation here, we've got air source heat pumps where we're taking air and moving it across a coil, much like an air conditioner, but in this situation, we'd be running the refrigeration cycle in reverse to extract heat from the outside air and transfer that energy to the indoor equipment. In this case, we have some ductless equipment inside, as well as one ducted unit. So in the winter months, the air coming out of this fan here would be cool, as we're taking that energy from the outside air, and in the summer months, we'd run it in reverse, and the air coming out of this would be warm, putting some cool air into the inside of your home. The equipment that we selected for this project is a Mitsubishi Smart Multi-Heat Pump. We have two systems, one for the first floor and one for the second floor. If you notice here, this Hyperheat logo, this equipment here is designed to run year-round, and it's an all-climate heat pump and designed to provide full heating down to minus 13 degrees outdoor temperatures. So year-round heating. If you notice, they're up on stands to keep them up off the ground if there's any snow or anything like that. They do have an automatic defrost cycle. So again, they're designed to run year-round, and they're pretty much bulletproof. That's why we selected Mitsubishi for this project. In this situation, there's two main areas in this building. The first floor is the meeting room. There's some admin areas. Upstairs is a museum and some other archives rooms. So you have two different load profiles in this building. So we decided to use one outdoor unit for each floor. That way we can operate the most efficient way possible in terms of what's required for heating and cooling on any given day. For instance, there's not a lot of folks up in the museum day in and day out. So we wouldn't want that unit to be working with a unit downstairs that might require more heating and cooling. So the biggest problem we find with these heat pumps is when they're oversized or overzoned. So we really want to pay attention and be thoughtful about where we're locating the equipment, how we're separating the zones by floor. So when looking at a contractor, it's really important that you work with a team that's going to provide a load calculation. As Patrick mentioned earlier, CET came in and did their survey and their load calculation. They do great work. We take that and we build off of that. We do a two-step load calculation to determine the heating and cooling requirements for each room in the building based on the lighting, the equipment, the people, and that kind of thing. Again, like I said a moment ago, oversizing and overzoning is the worst case scenario. So if the air conditioner or the cooling size is too big, it won't pull enough humidity out, and it'll be cold and clammy in the place, and it'll run incredibly inefficiently if it's turning off and on like a strobe light all day. We want this thing to run smooth, kind of like your car on the highway, cruise control at optimum RPMs. We want this thing to be running smooth and not be overworking and try to be in that sweet spot. What we're looking at here is what we call a ductless indoor unit. This is what they call a high wall ductless indoor unit. This unit is going to deliver all the heating and cooling to the space. When we look at placement of indoor unit, we want to think about aesthetics as well as operation. We want to make sure that we're going to deliver the right amount of heating and cooling to the space, but also be mindful about where we place the unit. In this situation, being the age and the aesthetics of this older building, we want to be super thoughtful about where we put the equipment. In this case, we put it on an end wall. We're going to come right outside with the piping and go down to the unit. And then for the other unit on the other side, we chose a low wall unit, and the piping will go through the basement. So very minimal impact on the outside of the building. Everything's located on one end of the building, as opposed to a spaghetti mess, all over the building. We think a lot about aesthetics and older buildings, and a lot of folks are saying, my house is too old, they can't put a heat pump in. We could put them virtually anywhere. The only thing that really holds us back is the electrical infrastructure, but that can be handled with a smart electrical panel as well, so to kind of balance out the electrical loads in the building. So when in the home, our design consultants will be able to provide a 3D model of each floor in your home, and this takes into account any windows and doors and insulation values, so we can really customize the design layout based on the heating and cooling requirements of your home. So the question was, what does the design process look like? What we want to do is first start off by when you call up our team, you'll deal with one of our residential concierge. What they'll do is take down a lot of information. We'll do some background information on your home. We'll pull the property of record card. We'll look at the home, make sure that we ask a few introductory questions to make sure we're sending the right team member out to your home. When we come out to your home, we're going to do a thorough diagnostic of your existing conditions. We're going to look at your home in terms of its insulation values. We're going to do a thorough load calculation at that time, and then we're going to select some different equipment options that are going to best meet your needs. In this situation here, we're going with primarily a ductless situation, but a lot of times folks are asking for a ducted heat pump in their home, which is another great solution. At Control Point, we do a thorough diagnostic of the duct airflow to make sure that we're selecting the right equipment that's going to match with your home. A lot of times, unfortunately, the ductwork isn't sized properly to handle a heat pump for your whole home solution, so we want to be really thoughtful about that to make sure you're getting the best bang for your buck. Another part of what we do is do a cost comparison. We take a look at where you're at now, where you want to go, what's important, and tailor the design around that. We can look at the cost of what your current system is running at versus what the heat pump would do before and after the insulation upgrades and that kind of thing. Our residential concierge team here at the office, they handle everything paperwork-wise, warranty registration, rebates. We deal with Mass Save. We're a partner with Mass Save. We have currently have a no-wait rebate program for Mass Save customers. We don't make you wait for the rebate. We take care of all the paperwork right up front, and we even help you with the heat loan. It's a really neat service that we offer. Our team is also fluent with everything SELCO related in terms of the SELCO heat loan, the SELCO rebate programs. Very importantly, you select a contract that's going to pull a permit. We pull a permit on every one of our jobs, and the folks here at Shrewsbury Building Department are really good at going through that with a fine-tooth comb. You're very lucky to be in Shrewsbury and have a building department that's going to be thorough like that and make sure that everything's buttoned up.
So there are multiple incentives for heat pumps that Shrewsbury residents can leverage. SELCO offers up to $10,000 for heat pumps through Next Zero. We also have a 0% financing loan program that's also up to $10,000. Those two can be combined. And then Eversource customers in town that have natural gas service can leverage Mass Save incentives. That is also up to $10,000 for heat pumps. If you're income qualified, it's up to $16,000. They also have the Mass Heat Loan. That's also 0% financing, up to $50,000 for heat pumps, up to $25,000 for weatherization. So you can combine Mass Save, SELCO, and then there's also a federal tax credit, 25C, up to $2,000. All of those things can be combined. And you can enroll your compatible smart devices into our Connected Homes program. It's a demand response program that shifts your load outside of peak hours a handful of times per month. So Wi-Fi thermostats, mini split controllers, EV chargers, heat pump water heaters can all be entered into that program, and you receive a consistent monthly incentive. We also have commercial rebates for heat pumps as well. Thanks to Control Point Mechanical, Shrewsbury Media Connection and the Historical Society for this project. Please visit our website for more details.